Okay, so we're given a problem here with an equation, and the equation has the x terms as unknowns, which is pretty standard, but it's also got an r value, and it's asking us to find the other solutions to the equation if it is known that x equals 1 is a solution. So this equation is a type of cubic because there's a power of 3, which is the highest power, which means that at most it's going to have 3 possible solutions. Now we're told that x equals 1 is definitely one of those solutions. Now the handy part about this is that particular piece of information can actually help us figure out what the r value is, because basically what it's saying is when x equals 1, this is true. So what we can do is we can actually let x equal 1, and by doing that, we'll be able to see exactly what this r value is that we're dealing with. So by subbing in x equals 1, and then by basically simplifying our problem, we can actually find that we've got 6 plus 5 equals r plus 1, which basically means that 11 equals r plus 1, and r is therefore equal to 10. Now, that is a fixed value, so that means we can actually rewrite the problem with r subbed in. So instead of this equation, we've now got 6x cubed plus 5x squared equals 10x plus 1. And once we've got that information, then it's just a basic cubic that we can solve. Not only that, but if we rearrange it so that we've got the entire polynomial equal to 0, we can actually use the fact that x equals 1 as a solution to help us find the first factor and to start factorizing it. Now the factorization process can either be done using long division, or if you've learned some other type like synthetic division or building up factors as you go, then you'll be able to work through it. For the moment, I'm just going to use long division, knowing that x minus 1 would be a factor. If you need help with where I got that from, you need to brush up on your factor theorem, which is covered in the polynomial section. So let's use long division quickly, and we'll use x minus 1 as a factor into the polynomial, which would be the entire cubic rearranged so that it was to equal 0. So that would be 6x cubed plus 5x squared minus 10x minus 1. And we can use long division to quickly solve it. So we'll put the x into 6x cubed, which would give us 6x squared, multiply down to give us the value that we need, subtract our values, and then bring down the negative 10x, and then we'll basically repeat the procedure. So we'll put the x straight into the 11x squared, multiply out again exactly like we did before, minus 11x, perform the subtraction procedure exactly like we usually do, so that would become 0, and negative 10x minus negative 11x would actually give us 1x, and we'll bring down that negative 1. And then finally, one last division. So x into the 1x will give us a 1. And then multiplying out would give us 1x minus 1, which gives us a remainder of 0. Division works perfectly, and we can say that the partially factorized form is now equal to x minus 1, 6x squared plus 11x plus 1. And then what we would want to do is factorize that quadratic, or use the quadratic formula in order to finish everything off. Now, because this is quite a complex quadratic, the quadratic formula is definitely going to be faster, so I'm going to use that. Taking this into account, I'm going to say that x is equal to the quadratic formula. Now, trust me, if you haven't memorized this formula, it's going to come in way too handy for you to be stuffing around with and trying to look for. So take the time to actually memorize that formula, you'll have a much easier time. X is therefore equal to negative 11 plus or minus the square root of 11 squared minus 4 times 6 times 1. And the whole lot is over 2a, which is 12. And then all you have to do now is focus on simplifying it down. So 11 squared is 121, minus 4 times 6 times 1 is 24, over 12. Continue simplifying, and at this point you'll be able to split apart the plus and the minus sign. So 121 minus 24 would be 100 and then another 3 off, so 97 over 12. Now it's a good thing we use the quadratic formula because this is turning into a very ugly solution. Take this and split it apart into two pieces. X is equal to negative 11 plus the square root of 97 over 12, or x is equal to negative 11 minus the square root of 97 over 12. And those two values would be your two missing solutions.